Now I will go to the next chapter, that is the electromagnetic induction. That is the electromagnetic induction. Okay, already you know in the previous chapter, magnetic flux, the number of magnetic flux magnetic field lines passing normally through that surface area, that is called as the magnetic flux. Or in other words, the product of the magnetic field into that surface area, that is called as the magnetic flux. Therefore, the magnetic flux, that formula is written like that: phi b is equal to b a cos theta, where b is the magnetic field, a is the surface area, theta is the angle between them. That is the angle between them. Clear? So this is the surface area is taken. So that is the field lines are lined normally through that area. That is theta. That one is the quantity theta. Clear? So that is the, this is the quantity your that is the theta. This is the magnetic flux. Magnetic flux. The number of magnetic field lines passing normally through that surface area, that is called as the magnetic flux. Or in other words, according to mathematical formula, that is the product of the magnetic field into that surface area, that is called as the magnetic flux. Okay. Now that is this magnetic flux. This magnetic flux is, if theta is equal to 0 degree. If theta is equal to 0 degree, then the magnetic flux is maximum. If theta is equal to 90 degree, magnetic flux is minimum. Okay, that is written like B dot A. B dot A. Okay. Now that is when magnetic flux is maximum, when magnetic flux is, that is the minimum. And the next one, the electromagnetic induction, the phenomenon in which EMF is induced in a coil due to the change in the magnetic flux linked with that coil. That is called as the electromagnetic induction. The electromagnetic induction is a one phenomenon in which EMF is induced in a coil due to the change in the magnetic flux linked with that coil. That is called as the electromagnetic induction. Or in other words, you say like that, that is also correct one. The phenomenon in which, that is the induced the EMF due to the change in the magnetic flux linked with the coil, that is also called as the electromagnetic induction. In the short form, in the short form, we write the like that: electromagnetic induction, EMR, electromagnetic induction. In the short form, we call it as the EMR. Okay, electromagnetic induction. Okay, that the next one, that is coil and magnet experiment. This experiment demonstrates the what is the electromagnetic induction. This, that is the experiment, coil and magnet experiment, demonstrates the what is the your, that is the electromagnetic induction. Clear? So that is the next one is the what is the your electromagnetic coil and magnet experiment. Very, that is the simple is there. That is the what is the one coil is taken. That coil is made by the copper. That coil is made by the copper wire. Across the copper wire, 1 galvanometer is, that is connected. Then what happens? Say this is the galvanometer. Now this is the galvanometer. Now this is the 1 bar magnet. This is the 1 bar magnet. This is the 1 and the bar magnet. Okay. Now this bar magnet is suddenly brought nearer to this coil. This bar magnet suddenly brought nearer to this coil. Then what happens? That is even, that is the magnetic flux linked with the coil. That change in the magnetic flux linked with this coil, the EMF is induced in this coil. Therefore, that is the induced current. Induced current is set up in the what is the coil. Therefore, the galvanometer shows the deflection. Galvanometer shows the deflection. Clear? Then that is the, see this is the what is it? That one, the same coil. Across the same coil, the 1 galvanometer, same galvanometer is connected. And across the galvanometer, same galvanometer is also same, that is connected across the coil. The same bar magnet is taken. Same, that is the bar magnet is, that is the taken, but that is the poles of the magnet is reversed. Poles of the magnet is, that is the reverse in. Clear? See this one. When this north pole of the magnet suddenly brought nearer to this coil, then change in the magnetic flux linked with this coil, therefore induced the EMF in this coil. So that the induced current is set up in the water in the coil. Therefore, galvanometer shows the deflection. When that is the poles of the magnet is reversed, the south pole of the magnet is brought nearer to this coil. South pole of the magnet suddenly brought nearer to this coil, then changing the magnetic flux linked with the coil, then the EMF is induced in this coil. Therefore, that is the induced current is set up in this coil. The galvanometer shows the deflection. But here, that galvanometer, initially galvanometer shows the what, that is the left side deflection, but that is in the second one, that is the galvanometer shows the right side deflection. It means what? That is the galvanometer deflection is in the opposite direction. It means what? Here north pole of the magnet and south pole of the magnet. It means what? The poles of the magnet is reversed. The galvanometer current is also the reversed. Galvanometer current is also that is the reversed. Okay? Then that is the next one, that is the most probably comes to in your mind, what is that? That is the, suppose the bar magnet is, that is a bar magnet is taken on the, that bar magnet is kept on the head of this, that is the coil. There is a no deflection in the yellow. The bar magnet is taken, that bar magnet is above the one this coil, kept constant or at rest position, but there is no deflection in the galvanometer. Why? Because of there is no change in the magnetic flux. There is no change in the magnetic flux. Therefore, there is no change in the magnetic flux. Therefore, galvanometer not show the deflection. There is no EMF is induced in that coil. Because of the statement is what? Change in the magnetic flux linked with this coil. Then linked with this coil, then that is the EMF is induced in that coil. Okay? The bar magnet is constant above the coil, nearer to the mirror, above on the coil. There is no deflection in the yellow. Why? Because of there is no change in the magnetic flux. There is no change in the magnetic flux linked with this coil. Therefore, the galvanometer not show the deflection. Okay? Anyway, this is the what is the battery. Okay? Now, the next one, another one is the what is the poles of the magnet. The pole strength is goes on that it is stronger. The pole strength is goes on that it is stronger and suddenly brought nearer to the coil. Change in the magnetic flux is more one. More EMF is induced in that coil. So that is the more induced current is set up in this coil. Therefore, that galvanometer shows more deflection. More, that is the deflection. Clear? Okay? That is the next one. And then another question is also comes to your mind. What is that? Sir, that is this bar magnet is kept in a constant or at rest position. This coil is suddenly brought nearer to this, that is the magnet. In that case, how? In that case, is it a EMF is induced in a coil? Yes. That is here induced the EMF in the coil. Induced the EMF in the coil. Therefore, induced current is set up in that coil. Then, so that galvanometer should be deflection. Because of what? The change in the magnetic flux is linked with that coil. Change in the magnetic flux linked with this coil. Therefore, it is the current. Okay? Therefore, that galvanometer shows the deflection. This is the Y-line magnetic field. It means what? Anyone in these two, anyone is that is moving or anyone is kept constant, then induce the EMF in this, that is the coil. Induce the EMF in this coil, then that is the induce the current is set up in this coil, then galvanometer shows the deflection. Okay? The next question arises in our mind. What is that? Is it that is that induced current or induced EMF is kept on? That is always that is constant? No. This is in a very small interval of time. This is action is completed, or this working is very completed. Because of that changing the magnetic flux linked with that coil in a very short interval of time. In a very short interval of time. Okay? This is this experiment demonstrates demonstrate the electromagnetic experiment. Okay. The next one, second one is the coil and coil experiment. This coil and coil experiment is also demonstrating the electromagnetic index. This coil and coil experiment also demonstrate the what is the electromagnetic index. In this case, there are two coils. Same coils are there. Same coils are there. Same two coils are there. Okay. Say this is the primary coil and this is the secondary coil. This is the primary coil, this is the secondary. There are two coils are there. First one is the primary coil and this is the secondary. Okay. Already we know the basic thing. In any conductor, the current is closed. The magnetic field is produced around that conductor. Magnetic field is produced around that conductor. This is already in the previous chapter, you know that one. Okay. Now, in the secondary coil, across the secondary coil, one anemometer is connected. Across the primary coil, one battery is connected, and that is the tapping key. That is the tapping key is connected. Clear? Tapping key. See, this is the secondary coil. Across the secondary coil, the galvanometer is connected. Across the primary coil, that is the one battery is connected, and that is the one tap key is connected. Okay? When the tap key is closed, the current is closed to the primary coil. When the current is closed to the primary coil, then that is produces the magnetic field lines. That magnetic field lines are linked with the secondary coil. Therefore, change in the magnetic flux linked with the secondary coil. Therefore, this galvanometer shows the deflection. This galvanometer shows the deflection. It means what? But these two primary coil, secondary coil is very closer to each other. very closer to each other, but not touch with each other. Okay? That is when this tap key is closed. When this tap key is closed, the current is flow through this primary coil. Then the magnetic field lines are produced. That magnetic field lines are linked with the secondary coil. So the magnetic flux, change in the magnetic flux linked with the secondary coil. That is the induced the EMF in this coil. So induced current is set up in this coil. So this galvanometer should be deflected. And that is this battery is reversible. Here also this battery is reversible. Then here also that is the tapping key is closely. The tapping key is pressed. Then the primary coil, the current is current going to this that is the primary coil. Then what happens? Change in the magnetic flux linked with the secondary coil. Therefore, induced the EMF in the secondary coil. Therefore, galvanometer shows the quantity deflection. So, but initially the galvanometer, that is the deflection in the left side, and that is in the this that is the battery terminals are the interchanges, then at that time the yellow meter reflection is also that is the opposite to initial one or in the right side. Like that, this is the what we did while. This is the what we did while that is the experiment. Okay, these two experiments, coil and magnet experiment and coil experiment, that will demonstrate the electromagnetic induction. Okay, now that is the next one in the Faraday's law of electromagnetic induction. The induced EMF in a coil, induced EMF in a coil, the induced EMF in a coil is equal to the rate of change of magnetic flux. Rate of change of that is the magnetic flux. So that is the Faraday's law. See, this is the E is equal to minus d pi divided by d pi v divided by that is the d. Okay, this is the one the Faraday's law, the induced EMF. The induced EMF that is written like that also. This is also correct. The induced EMF in a coil is equal to the rate of change of magnetic flux. That is your Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Okay, this minus sign indicates the induced EMF and induced current direction is opposite to each other. Induced current and the induced that is the EMF is opposite to each other. Clear? So here this that is supposed to write like that. Y is equal to minus R into d by d divided by dt. This N it represents the number of turns. Number of turns that that is the coil that is the contains that coil contains the number of turns. Here it means what? There is a no N, it means what? Number of turns is only one. Number of turns is only one in this. Suppose you are right like that. That is the right like that. Number of turns, where it is the number of turns. It may be 2, it may be 4, it may be 10, like that. That is the coil contains the number of turns. And this minus sign contains the wanted your change in the magnetic flux, or that is the induced current and the induced EMF are in the opposite, that is the direction. Opposite, that is the direction. Clear? The next one is the Lenz's law and law of conservation of energy. The law of conservation of energy. The polarity of the induced EMF. The polarity of the induced, that is the EMF is such that it tends to produce the current, or that is the cause of which produces it, which opposes to the cause of which produces it. That is called as your Lenz's law. The polarity of the induced EMF. The polarity of the induced EMF which opposes to the cause of which produces it. Induced EMF polarity ಏನಿರುತ್ತದೆ, ಎದಕ್ಕೆ ವಿರುದ್ಧವಾಗಿರುತ್ತದೆ ಅಂದ್ರೆ ಯಾವುದನ್ನು ತಯಾರು ಮಾಡ್ಯದ, ಯಾವುದನ್ನ ಉತ್ಪತ್ತಿ ಮಾಡ್ಯದ ಅದರ ವಿರುದ್ಧ ದಿಕ್ಕಿನಲ್ಲಿ ಇರುತ್ತದೆ. ಇಂಡ್ಯೂಸ್ಡ್ ಇಎಂಎಫ್ ಎದರಿಂದ ಬಂದದ ರೀ? ಚೇಂಜ್ ಇನ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಲಿಂಕ್ ಟು ದಿ ಕಾಯಿಲ್. ಓಕೆ, ಅಥವಾ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್ ಎದರಿಂದ ಬಂದದ? ಇಂಡ್ಯೂಸ್ಡ್ ಇಎಂಎಫ್ ನಿಂದ. ಹಾಗಿದ್ದಾಗ ಇಂಡ್ಯೂಸ್ಡ್ ಇಎಂಎಫ್ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್ ಒಂದಕ್ಕೊಂದು ಏನಿರ್ತದ? ವಿರುದ್ಧ ದಿಕ್ಕಿನಲ್ಲಿ ಇರ್ತದೆ. ಅದಕ್ಕೆ ಏನ್ ಹೇಳ್ತಾನಂದ್ರ ದ polarity of the induced EMF, it opposes to the cause of which produced it. It opposes to the cause of which produced it. That is called as the Lenz's law. That is called as the Lenz's law. And the next one is the law of conservation of energy. Law of conservation of energy. Already know that is a while in a magnetic experiment, when north pole of the magnet comes nearest to the coil, then that is changing the magnetic flux linked with the coil. Therefore, that is the EMF is induced to the coil. So, induced the current is set up in across the coil. So, the galvanometer should be different. Suppose that poles of the magnet is reversed. So, pole of the magnet is suddenly brought nearer to the coil. Then, changing the magnetic flux linked to the coil. Then, in that case also, that is the EMF is induced across the coil. So, that is the induced current is set up. The galvanometer shows the deflection. But that galvanometer deflection is in the opposite direction. Opposite, that is the direction. So, that is verified or valid your law of conservation of energy. This is Lenz's law. That is your law of conservation of energy. Now, that is very simple one. That is, you say that one. That is a coil and magnet experiment that verify the law of conservation of energy. Okay. ಇದು ಇಷ್ಟು ಜನರಿಗೆ ಇವತ್ತಿನ ಕ್ಲಾಸಿನಲ್ಲಿ ಆಗ್ಯದ. ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ 6ನೇ ಒಂದು ಅಧ್ಯಾಯ ಇದು. ಈ ಒಂದು ಅಧ್ಯಾಯದಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅನ್ನುವಂಥ ಒಂದು ಅಧ್ಯಾಯದಲ್ಲಿ ಮೊದಲಿಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ನ ವ್ಯಾಖ್ಯವನ್ನು ಅಥವಾ ಮೀನಿಂಗವನ್ನು ಮತ್ತು ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮವನ್ನು ನಮಗೆ ಗೊತ್ತು ಮಾಡಿಕೊಂಡಿದ್ದೀವಿ. ಹೌದಾ? ಯಾವಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಅದರ ಯಾವ ಸರ್ಫೇಸ್ ಏರಿಯಾ ತಗೊಂಡಿರ್ತೀವಲ್ಲ ಅದರ ಎರಡರ ಗುಣಲಬ್ಧ ಏನು ಕೊಡ್ತೈತೆ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸವನ್ನು ಕೊಡುತ್ತದೆ. ಅದೇ ರೀತಿಯೇ ನಾವು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಬಿ ಎ ಕಾಸ್ ಥೀಟಾ ಅಂತ ಬರೀತೀವಿ. ಆವಾಗ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಡಿಗ್ರಿ ಇದ್ದಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಏನಾಗ್ತದೆ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರ್ತದೆ. ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 90 ಡಿಗ್ರಿ ಇದ್ದಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಮಿನಿಮಮ್ ಬರ್ತದೆ. ಇದನ್ನ ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟರ್ನಲ್ಲಿ ನಾವು ಕಲಿತಿದ್ದೀವಿ. ಇನ್ನು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? ಇದು ಒಂದು ಫಿನಾಮಿನಾ. ಈ ಫಿನಾಮಿನಾದಲ್ಲಿ ಏನಾಗ್ತದೆ? ದ EMF ಇಂಡ್ಯೂಸ್ಡ್ ಆಗುತ್ತದೆ ಅಕ್ರಾಸ್ ದಿ ಕಾಯಿಲ್. ಯಾವಾಗ ಚೇಂಜ್ ಇನ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಬದಲಾವಣೆ ಏನಾಗ್ತದಲ್ಲ, ಆ ಬದಲಾವಣೆ ಆಗತಕ್ಕಂಥ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಆ ಕಾಯಿಲ್ ಜೊತೆ ಲಿಂಕ್ ಆದಾಗ ಮಾತ್ರ ಅದು EMF ಇಂಡ್ಯೂಸ್ಡ್ ಆಗುತ್ತದೆ. ಅಕ್ರಾಸ್ ದಿ ಕಾಯಿಲ್ EMF ಇಂಡ್ಯೂಸ್ಡ್ ಆಗುತ್ತದೆ. ಅದಕ್ಕೆ ನಾವೇನು ಅಂತ ಕರಿತೀವಿ? ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಥವಾ ಅಂತ ಫೆನಾಮಿನಾಕ್ಕೆ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ರೀತಿಯೇ ಕಾಯಿಲ್ ಅಂಡ್ ಮ್ಯಾಗ್ನೆಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ಏನು ಡೆಮಾನ್ಸ್ಟ್ರೇಟ್ ಮಾಡ್ತೈತೆ? ಇವರ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅನ್ನು ಡೆಮಾನ್ಸ್ಟ್ರೇಟ್ ಮಾಡಿದೆವು. ಅದೇ ರೀತಿ ಕಾಯಿಲ್ ಅಂಡ್ ಕಾಯಿಲ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ಇನ್ನು ಫ್ಯಾರಡೇಸ್ ಲಾದ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮ್ ಈ ರೀತಿ ಬರ್ತದೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇನ್ನು ಲೆಂಜಿಸ್ ಲಾ ಮತ್ತು ಲಾ ಆಫ್ ಕಾನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿ. ಇಷ್ಟು ಈಗ ಇವತ್ತಿನ ಕ್ಲಾಸಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದೆವು. ನಾಳಿನ ಕ್ಲಾಸಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಮೋಷನಲ್ ಇಎಂಎಫ್ ಅನ್ನುವಂಥದ್ದು ಬರ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಅದನ್ನು ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ.